There were two main ocean currents between 1.2 and 5 billion and 500 million years ago. Now, one current flowed from Australia to Southeast Asia to China, and then across the USSR into Europe and down the eastern coast of America, back across northern Africa and back to Australia. Now, this current carried blue-green algae from Australia into Norway, into Sweden, and into Scotland. Now, the other water current ran from South Africa across Antarctica, which was situated right here, and then it went into South America, Central America, and into the Grand Canyon region of Colorado, the fresh water. And it carried blue-green algae there around 750 million years ago. Now, all of these algae in all these different places build up the oxygen level. And by 700 million years ago, the oxygen requirements were met for the evolution of animals with circulatory systems that take in oxygen by way of the hemoglobin molecule. Now, the first multicellular animals were tiny, segmented, free-living invertebrate annelid worms. In other words, invertebrate. They didn't have any backbone. Now, the oldest fossils of these worms were found in South Africa and southwestern Australia and date from 650 million years ago. Now, they evolved from this little thing like one of these little unicellular plants with a flagella, and it evolved into an annelid worm. Now, the annelid worms have a closed circulatory system with blood plasma that they evolved from seawater. Now, that's where we inherited our blood plasma from that little worm. And we also had the beginnings of our nervous system there. The worms have a bilobe brain and a pair of connected nerves that encircle their digestive tract. And it forms a network or plexus right in the gut. And if you look in Webster's dictionary, it'll tell you that man has a solar plexus. We inherited that from the earthworm. You know, that's the pit of your stomach. And you know how when something happens and you feel it right here, like a ton of lead. Okay, now, the annelid worms multiplied rapidly. The worms of South Africa developed like a mineral casing, a kind of a shell skeleton. But the worms of Australia were soft-bodied, and they spread everywhere except South America and Antarctica. Now, around 590 million years ago, this wave of reincarnating spirits came in, and they evolved annelid worms of South Africa into brachiopods. Now, brachiopods are small invertebrate animals, no backbone. I think we got a picture of a brachiopod. Let's see, just a minute. Yeah. This is a brachiopod right here. It has a little shell. Now, that little thing evolved hemoglobin. It had hemoglobin floating around in its plasma, and that's where we got our hemoglobin from. We inherited it from them. Now, brachiopods became abundant around 590 million years ago. And at the same time, the annelid worms, this is a worm, in South Africa evolved echinoderms. Now, echinoderms have this calcium plate, so that's when they were learning how to make bone, etc. So now with the echinoderms, that's all these little starfish like this. Those are echinoderms. And annelid worms of Australia, most paleobiologists state that the trilobites, the annelid worms of Australia gave birth to trilobites. And most biologists state that the trilobites originated in the dark ocean depths. And the oldest fossils of trilobites were found in Europe and British Columbia. And they too date from 590 million years ago. Now, these first trilobites, some of them were about 0.02 inches long and some of them were about 28 inches long. And they had a nervous system just like the annelid worms. They had solid armor. They had compound faceted eyes. You know how you've seen these insects with these eyes look like little sections all over. And they had antennae and paired appendages, or legs were starting to appear. Now trilobites were meat-eating carnivores, incapable of manufacturing food and raw materials. They fed on smaller life forms and fertilized the eggs of the other life forms. So therefore they increased rapidly. They were all their descendants out there. Now around 580 million years ago, there were 21 different major trilobite categories. And they spread to all the continents. And this is let me show you what a trilobite looks like. I have some here. Here's a trilobite. Right here. These ugly things. Right here, and right here. Okay, they spread to all the continents, and 75% of the life forms on Earth were these things. Okay, now trilobites fertilized the eggs of brachiopods, and mollusks appeared. Now mollusks are like the snails, the clams, the horseshoe crabs, the octopus, the squid, the nautilus. So they, and those things also had the same nervous system that the worms had. Now brachiopods use iron, but the squids, the mollusks, use copper to transport their oxygen. Okay, trilobites fertilized echinoderm eggs, and cylinderates evolved. Now cylinderates are things like hydra and the jellyfish. Now if you remember, I think it was Will Smith in 7 Pounds. He put that jellyfish or hydra in the bathtub with him. They usually sting their prey and paralyze it. In some cases, the sting is fatal. So in other words, trilobites were breeding all these predators. They were fertilizing the eggs of the non-predators and breeding predators. Okay, trilobites were also the ancestors of insects. And that's the largest category in the whole animal kingdom. They have spiders, scorpions, ticks, mites, crabs are all insects, arthropods. And when you think about evolution, the evolution or materialization of any well-designed and organized creation is always followed by an avalanche of unplanned, unorganized, copycat imitations. You know what I mean? It's just like if you design a new movie or something, or a new dance, a new way of singing. Everybody's going to copycat, but they can't quite reach that original. So eventually, all of those copycats concentrate, and they can't quite make the high note of the original. And so then they start enslaving and destruction. And that's just what happened in the animal kingdom. Now sponges appeared 550 million years ago. Now sponges are slave colonies. You have a whole lot of unicellular cells in there. And they function as one organism. Some of them produce food, others just eat the food, and some of them just rule the others. But that's not one animal, it's a group of animals. The same thing with corals and graptolites and bryozoans, and all of these formed around 50 million years ago. That's a lot of difference. Now conodonts were tiny little worm-like life forms. They were only about 0.7 inches long. Now they evolved in South Africa around 510 million years ago. And they were essentially worms in the process of becoming fish. They were evolving to fish. Now, gaseous spirits passing through the earth made great folds in the crust of Europe and North America around 500 million years ago. These worms, these fish were evolving, and these were spirits coming in to help evolve this fish. Now the Earth's crust was uplifted some 5,000 feet, forming a belt of mountains from North America through Ireland, Wales, Northern England, and Scotland, all the way to Norway. Now as the mountains lifted, a trough formed and became an ocean. They called it the Iapetus Sea. And that divided the northern and southern hemispheres. Okay, North America, Greenland,